In this video, we're going to look at more solving radical equations. We've already dealt with a lot of square roots in equations, but what about equations that have cube roots or fourth roots or any kind of root? Let's just look at a couple examples and it might help us to clarify it. In this problem, we're asking for the value of x that would make this statement true, that the fourth root of x plus 7 would equal 2. Since this is the fourth root, if we raised everything to the fourth power, our index and our power, our exponent, match, and therefore we would eliminate that radical. So we would have x plus 7, no longer in the radical, equals 2 to the fourth, which is 16. Subtracting 7 from both sides, we get x equals 9. Now remember, as we did with the square root problems, we have to check our solutions every time because we might be getting extraneous solutions. So we're going to plug in that value, that 9, and we find that 9 plus 7 is 16, and the fourth root of 16 is in fact 2. So therefore, x equals 9 is a solution to this problem. Let's look at a few more examples. Here we have the cube root of some number equals -5. Since we're talking about the cube root, we make sure that our exponent matches our index. So we have 3. So we raise both sides of this equation to the third power, and we get x equals -125. We need to check our solution, and indeed the cube root of -125 is -5, and so therefore it is our solution. Our next problem. We've got 2 equals 1 over the cube root of x. Well, the fact that it's in the denominator really doesn't make any difference that this is still a cube root, and so the way to eliminate the radical is to raise it to the power of the index. And that will get rid of that cube root that's on the right-hand side. So we'll get x equals 1 over 8, 8 equals 1 over x. And then what we need to do here, since we just have one number equals a fraction, we can take the reciprocal of both sides, and we would get 1 over 8 equals the reciprocal of 1 over x, which is just x. We check our solution, we plug that back in and find the cube root of 1/8 is 1/2, but 1 over 1/2 is equal to 2. So it checks out, and we've got an answer of it. 1/8 equals x. In our third problem here, we have 5 square root of x plus 1 equals 7. We could just square both sides to solve this, but let's isolate that square root even more by first dividing by 5. And granted, we have a fraction here, but we're just going to be squaring both sides to eliminate the radical. And we get that x plus 1 equals 49 over 25. We subtract 1 from the left-hand side, and we're subtracting 1 from the right-hand side, but in the form of 25 over 25, so that we can subtract those two fractions. We have 49 25ths divided by 25 25ths. And we get x equals 24 25ths. And you should plug that back in, add it to 1, take the square root, multiply it by 5, and you will find, in fact, that it does equal 7, and so therefore it is a solution. But looking at these past 4 problems that we've done, the one on the previous page and these 3, every single one of them has a solution. Is there always going to be a solution when we have radicals? We've talked about extraneous, where we might get 2 solutions and one of them doesn't work. But do we ever have any problems with radicals where we get no solution whatsoever? Let's look at this square root problem. It's saying the square root, find the value, it's asking us a question. Find the value of x such that the square root of x plus 3 is going to equal -8. But remember, this is the principal square root, meaning the positive square root. And this is saying that a positive square root is going to equal a negative number. Well, there's no value of x that's going to make this statement true, because positive square roots, principal square roots, will always equal positive numbers. So there's no solution in this case. So here is a case where there is absolutely no solution that will make this statement true. Let's look at this other one. When we've got positive square roots, we have a positive answer, so that's not like the previous problem. So we're going to go ahead and solve this like we learned before, where we isolate one of the square roots. So I'm going to get rid of the square root of x on the left-hand side, so that I've isolated the square root of x minus 9. Square both sides to eliminate that radical on the left. x minus 9 equals 1 minus 2 square root of x plus x. I still have a square root, so I need to now isolate that one. Subtract 1 from both sides, subtract x from both sides, write it over here on the right, and I get negative 10 equals negative 2 square root of x. I'm going to isolate that square root even further by dividing by negative 2, and I get that 5 equals the square root of x. So I square both sides, and we get that x equals 25. But remember, we have to check our solutions. And we only get one solution here, so we'd think, okay, it's going to work. Let's plug it in. So I have my original equation, plugging in 25. Now think about that. 25 minus 9 is 16. Square root of 16 is 4. Plus the square root of 25 is 5. 4 plus 5 does not equal 1. So here's a situation where we have no solution at all. There is no solution to this problem. So is there always a solution? No, there's not always a solution. And sometimes that non-solution, where there's no solution, is something that's rather kind of, I wouldn't say obvious, but here it's a simple reason why there's no solution, that a positive square root cannot equal a negative number. Other times, it isn't until we plug it in and we find that we're not going to get the value which we ask for, and so that one algebraic solution is an extraneous solution, and therefore there are no solutions to that problem.